All right. I'll start with the introductions. I'll start with what's on the agenda today. Start with the introductions of our esteemed guest today, and then we'll move on to what's the content for today's special day. We have our day, National Space Day, that marks a significant event in our historical ISRO's soft landing missions. So we'll start with what we have done for a bunch of stuff like that. Okay. So let me introduce myself. I am Yashraj Singh, one of the founding members of Propagation. We do a bunch of stuff. We do programs, trainings, internships, and projects. We specialize in making you very aware about space sciences and AI. A bunch of our stuff is very, very unique. You won't find it anywhere else. So that's what we do. That's our mode. We have very specialized bunch of individuals in our team. So that's what we do. Now for today's agenda, we have our very esteemed guest, Mr. Sibsankar Patil, who has told me not to call him sir, but we respect him very much. So I'll just explain to you who he is and why he's here today. He is the founding and executive director of Live 2 and Beyond Foundation. He has done a bunch of work educating a bunch of individuals in space science and as biology. And I mean biology in this field of astrobiology in the sense. He has contributed to a bunch of projects. He has done a lot of freelance work. He has educated so many individuals that he is the one who is fit for today's space science event. The significance of today's event stems from us marking a National Space Day where Chandrayaan 3 did a soft landing on south side of the moon. So a few instructions for you before we start. If you have any questions, do type it in the chat. You can just type in the chat. Sir will take it at the end. And we'll also take audio questions. So you can do it there as well. Now, if you stick to the end, we'll have a very special announcement for you because we are launching a winter school, which will be very beneficial for you if you're very interested in astrobiology and astrophysics. All right. I'll let Sir begin now. Enough from me. Now, I'll let Mr. Sibsankar Patil begin. Thank you, sir. You can go ahead.
Thank you, Yash. I'll just take a moment to share my screen. First of all, hello everyone and happy National Space Day. While I share my screen, a few things I just want to share with you all. Just a second.
I think somebody is not muted his mic. So you can start here.
Yes. Is my screen visible properly?
Yeah. Yes, sir.
Before I start, I just want to make a few things clear for all. Is that the poster seeing which you all have joined today says it's an interactive session. So it's not me blabbering a lot about the missions and what the ambitions of the Indian space program are. I would also expect some of you to write something in the chat, as well as from time to time we can also switch on the audio. Maybe I can ask you all to answer certain things. And at the end, we can also take up some wonderful questions. So today is a National Space Day, and today we'll be discussing more about the Indian lunar exploration journey since the beginning of this century. And also the ambitions. Like we know, the Indian space program has become popular a lot globally in the recent years because of one very important mission we know as the Chandrayaan 3. Before that, India has done a lot of wonderful work in the domain of lunar science exploration or like Martian exploration and all. But then still, Chandrayaan 3 remains as a classic example that kind of sought the attention of the entire world towards India, which used the modest of resources to reach the moon and at a place where no one have ever reached. So without further ado, I would just like to begin today's discussion. Again, Happy National Space Day. This year we have the theme from the Indian government and ISRO. That is Aryabhatta to Gaganyaan, ancient wisdom to infinite possibilities. Here, Aryabhatta, obviously, you can consider the great mathematician Aryabhatta or the Aryabhatta satellite, the first satellite that India launched from here. It's 50 years since Aryabhatta satellite was launched back in 1975, and it's no longer in orbit, obviously. And the Gaganyaan mission, like recently, ISRO chairman Dr. V. Narayanan was mentioning that by the end of this year, I think so in December, non-human space flight consisting of the Vyomitra, the female humanoid robot on it and all. So a lot of possibilities exist in the upcoming days for the Indian space program. And obviously, not to forget, thanks to Propagation team and to SA Citizen Science for this opportunity to get an audience like you all to come together and discuss this thing on this day. And just a bit about myself. I'm Sibsankar Palit, not Sibsankar Patil, not from Gujarat, I'm from West Bengal. And I'm a space entrepreneur. I run the Life to and Beyond Foundation, which is a non-profit organization, space organization, which works with space biology and astrobiology. And alongside, we also work with space law and economics, and obviously space education. So these are some of the broader fields that we work in. And myself, I work in the field of space chemistry, essentially with regard to space biology, like certain technologies and biosignature detection and cataloging with regard to astrobiology. So these are some of my specific research works. And obviously, I am a science communicator. And today I come here in front of you all to discuss this as a science communicator rather than a lunar science expert. So there are certain advantages and there are certain disadvantages when it comes to becoming a science communicator. For a science communicator, one may or may not be an expert in a particular field. Let's say for the lunar science, I'm not an expert. But at the same time, being a science communicator, it increases my spectra, or let's say my connection to a broader set of people with whom I have interacted to date, and let's say like exchange knowledge, which I'm here to share with you all and discuss with you all in a less jargon format. So I represent a number of organizations, but mainly Life to and Beyond Foundation. Alongside that, I'm also a member and on the board of directors of certain other global space organizations, some of which like the ACS Worldwide, which is an observer status organization of the UN COPUS, like SGAC and Moon Relay Association and all. So that's a brief about myself. Now, today's session is not about myself. It's about the Indian space program. So when it comes to the Indian space program, one person often whose work we do not acknowledge much and whose vision we do not remember much is obviously Dr. Vikram Ambalal Sarabhai, the man, and along with his team, who envisioned a space program for a country like India, and who was not just a space scientist, okay, to be more apt. He was a physics person, but he went on to do a ton of things. Like, let's say, he went on to found the Vikram Sarabhai Community Science Center, like a science museum kind of thing in Gujarat, to even like setting up the scientific organization for a textile industry. Okay, so that we can have high quality textiles made in India. Okay, today we hear a lot about Make in India and all. This didn't start anew. This started long back from Vikram Sarabhai, or let's say even before. Okay, and then he was the first person who started the IIMs, let's say the IIM Ahmedabad, and we know it led to many other IIMs. He basically wanted to foster the very spirit of project management, the importance of project management within the country and its training. And so to train such individuals um, he created the IIMs. Unfortunately, in today's greater trend, we see IIM graduates going to high-paying jobs outside India. But then that was not the vision with which IIMs was found, unfortunately. And obviously, he went on to lead the Atomic Energy Commission after the death of his very dear friend and peer group person, Homi Bhabha. So he also led the nuclear program and found a number of institutions. And obviously, he kind of encouraged younger people like you and me that time, let's say Abdul Kalam, or even there are other examples who went on to work in ISRO or other organizations beyond ISRO, means fostering that project development, project management spirit and using science for the betterment of society. Okay. And these are some of the organizations you can see he found, like the PRL, ISRO, the Space Application Center in Ahmedabad, and then VECC, the Variable Electron Cyclotron Center in Kolkata, and then also Department of Atomic Energy, which he led. And obviously, the most important is ISRO. That is the one for which he is mostly known for. And he conducted a lot of experiments. One of the most important one being the TV broadcast in villages nearby Delhi. It's a very big project using NASA satellite. It is to date the biggest educational experiment done using space technology. So impacting so many villages, like the Doordarshan that we know, that was kind of broadcasted that time using satellite technology in the remotest parts of India. So that was done by ISRO under the leadership of Dr. Vikram Sarabhai when he was alive. But then, as they say, a leader is not one who does everything during his lifetime, but then he creates an environment such that when he is not there or she is not there or they are not there, the organization can go on, the good work can go on. And that is what Vikram Sarabhai stands for. So Vikram Sarabhai was a multifaceted individual at Life to and Beyond Foundation. In his honor, we started the Outreach Sarabhai initiative 3 years back, which has impacted a lot through online or even in the remotest parts like in Chhattisgarh or West Bengal or Rajasthan and UP and other parts of India. So in his honor as well today, obviously, when we are talking about the National Space Day, his story is obviously meaningful to discuss. Okay. Now, that's about Vikram Sarabhai. But then Sarabhai, when he started Indian space program, he didn't envision like the moon missions or human spaceflight missions. He started the Indian space program for the application of the citizens of India. Okay, predominantly. But then today we have been to the moon, we have landed on the moon, we have been to Mars orbit, and now we are also
Oh, sir, you are muted, sir. So just unmute yourself. You are muted, sir. Yeah, okay, sir. Just try now.
Yes, sure. As I was discussing, that for the Chandrayaan series, it didn't start something when Vikram Sarabhai was there, but he envisioned for these at that point in time when INCOSPAR, like the first initial form of ISRO, started in 1962, 1963, and then it officially got recognized in 1969 on 15th of August as ISRO. So that time it was focused more on civilian application or like for the betterment of the citizens of the country, or the Republic of India. But now we are going to the moon, we have been to Mars and human spaceflight missions. and multiple other things like Venus will be going to Venus soon, and like even collaborative missions will come up. So a lot of things to discuss. But then today is special with regard to the Chandrayaan series. Now, why the moon? Like, obviously, there are multiple reasons to go to the moon, right? And um, some of the most important things when we come to the moon missions, like the scientific motivation. Some of them are listed here, some of them are not. Like some of them that you know, obviously, is it's an airless body, and means it doesn't have an atmosphere. So unlike our Earth, like if we have an atmosphere, we are lucky enough, but at the same time unlucky enough in the sense that it doesn't allow certain wavelengths of electromagnetic radiation, or let's say the different kinds of waves to pass through it. It gets reflected, or let's say some gets trapped within the Earth's atmosphere. So light itself is a light, or let's say most importantly, electromagnetic radiation helps us understand things, helps us better analyze things without even touching that particular thing or coming in contact with a particular thing. So remotely we can collect light signatures or electromagnetic signatures and understand what that thing is made up of, be it its physical or chemical or biological features. Okay, so that is what we call remote sensing. So when it comes to the moon, there's no atmosphere, so it becomes easier that even like with a satellite or an orbiter around the moon, we can study a lot of things. And it doesn't have any magnetic field. So unlike our Earth, which kind of reflects back, or not reflects back, some part is reflected and some part is kind of like forms the aurora borealis or aurora australis, as we know, on the two poles of our Earth, when the solar flares consisting of highly ionized particles collide with the magnetic field of Earth. But then on moon, there is none. So what happens? The solar flares, like the ionized particles are there in the exosphere of the moon, or the like the atmosphere of the moon, and then also like the helium-3, we know helium, the element, and its isotope with mass number 3, it gets deposited on the lunar surface. This is called lunar regolith. Okay, like a collection of like layer after layer of helium-3 isotope material from the solar flares. So what happens? Helium-3 is a radioactive element, we know, and it can fuse together to form to give nuclear energy. And in fusion, we know there's greater amount of energy. So in future, like if we mine this helium-3 a lot from the moon, we can also set up nuclear power plants or nuclear reactors up there on the moon to generate nuclear energy out of them. And obviously, like as we move to the other planet, we expand, because earlier we humans, as they say, we were all members of Africa, like with our ancestors spread across the world from Africa to different continents. Earlier we were there on one continent, now we are multi-continental. And now we are on one planet, we aim to become multi-planetary, or let's say multi-celestial species, so that we are not only there on Earth, but also on the moon, Mars, and other planets or moons, right? So these are the three major reasons. One is to study the moon, which gives us an understanding, so a scientific or a fundamental understanding of what the moon is. Even like, as you all may know a bit, that the moon was actually formed as per the giant impact theory, that when a Mars-like big object at a point in history, Earth's history, hit Earth, a part of Earth only got separated as moon. So like on Earth we have atmosphere, but on moon we do not. So there is no weathering or like geological activities much on the moon. So let's say the moon has been same since then, let's say 4.4 billion years back, something like that. So if we study the moon, we can also understand the early form of Earth. Okay, that's the first reason. Second, obviously, helium-3 deposits. And third is expansion of humanity beyond Earth. So these are the three main reasons. And to date, scientists have tried to understand the elemental composition and the mineralogy and the geology and exospheric studies and the particles present in the outer environment of our moon. So these are enough actually to go to the moon. There's reasons enough to go to the moon. Okay. And this is beyond just Indian missions. It is applicable for American, Russian, Chinese, and other missions as well. Now, Chandrayaan series in brief, if I say, Chandrayaan started back in 2008, like Chandrayaan 1, and then Chandrayaan 2, 2019, and then Chandrayaan 3, 2023. And we are standing 2 years after that, 2025. So the envisioning of Chandrayaan started in 2001, 2, 3, that time. Okay, and then eventually the first mission, the orbiter mission, like a satellite kind of thing, which would move around the moon, went in 2008. And then there was a hard landing probe. Like, let's say if I take any object and throw it like at a very fast speed and it impacts hard on the surface of any land, then that's a hard landing. So 2008 mission consisted of these two major things. One is the satellite or the orbiter around the moon and the hard landing part. So that point where this hard landing took place, we call it as the Jawahar point after our first Prime Minister, Jawaharlal Nehru. And then Chandrayaan 2. Chandrayaan 2 went to the moon. It consisted of three things: the orbiter, and then the lander named Vikram, and the Pragyan rover, or the like robotic car that came out of the Vikram lander. So 2019 it went to the moon. The orbiter was successful for deployment in orbit, but then the lander and the Pragyan rover unfortunately crashed at a point we now know as the Tiranga point after the Chandrayaan 3. So Chandrayaan 2 was about all of this. And Chandrayaan 3, which was kind of a retake of the Chandrayaan 2 mission that didn't succeed, the part of Chandrayaan 2 that didn't succeed, which included the Vikram lander soft landing near the lunar south pole, and obviously the Pragyan rover, the car coming out of the Vikram lander. It included these two parts. And obviously a successful part of Chandrayaan 2, that is the orbiter part, was also used for proper landing of Chandrayaan 3. So it's not that Chandrayaan 2 was a failure, it was an in-part failure. Okay, and science is all about, let's say, hit and try and fail. Okay, and then you learn again and you try again, right? So it is a journey of perseverance. Just to keep it in one line as it is described here, these three missions, it was to understand moon better in a chemical manner and mineralogically, and its geological mapping, like to better geologically map the moon. These three missions altogether contributed in that way. Okay. And each of these missions had their own set of payloads. I'm not going to discuss all of that because each one would take a lecture in itself. Okay. And the science from Chandrayaan 1 to 2, like you can see, I'm not going into much detail here. These are the payloads of Chandrayaan 1. These are the payloads of Chandrayaan 2. These are the specifications of Chandrayaan 1's payloads, and these are improved specifications of Chandrayaan 2's payloads. So these are the enhanced science. Like with each mission, they have enhanced the scientific questions and to better understand the chemical and geological mapping and the mineralogical composition of our moon. Okay. One of the more key things to understand here is Chandrayaan 1 was responsible, like a payload on the Chandrayaan 1, basically one of NASA's payloads, was responsible for detection of these hydroxyl like molecules, or you can say a detection of hydroxyl ions and water, and like in the form of ice. The signature of water was found in the lunar south pole. Okay, and later on, through remote mapping in Chandrayaan 2's orbiter also, further, let's say, kind of validated it, mentioning that these water or these ice were present in the dark craters, kind of like dark regions in the lunar south pole. And that is why, like, that is one of the major reasons why we chose the lunar south pole as a point of landing. Okay, like near the lunar south pole, not exactly lunar south pole, near the lunar south pole. Okay. Now, same goes for Chandrayaan 2 to Chandrayaan 3. A lot of, let's say, enhancements were done in terms of the payloads. Okay. From studying plasma to studying elemental composition to understanding like temperature, like how temperature changes in the lunar soil, all of these components were added. Okay. You can find all of these details on ISRO's website. I'm not going to discuss all of this because these are not important in context of this entire talk. What's more important is what Chandrayaan 2's failure, the part that failed, could offer for Chandrayaan 3 such that it would become a sure shot success. Okay. So there were improvements done in software, in sensors, in propulsion systems, and then like they also reworked the touchdown limits and also improved the mission plan to altogether. And then improvements in the NGC, then exhaustive simulations and ground tests were done. And also in the propulsion module, like the one during the soft landing, those propulsion modules were also improved. And then the hardware was also like made more redundant in terms of making the Chandrayaan 3 soft landing an absolute success. Okay. In fact, if you have followed the Chandrayaan 3, like, or the Chandrayaan series for long, like you must have known or understood at least to some extent that when Chandrayaan 2 happened, like some level of confusion still was there. But on the Chandrayaan 3, like that evening when Chandrayaan 3 landed, it meant altogether that it was going to be a success. So like a lot of improvements were made in terms of like software, hardware, and propulsion modules and so on that led to the success of Chandrayaan 3 eventually on 23rd of August in 2023. Now, why land near the lunar south pole, a part of which I have discussed already, but then there are a few more details to it. This map you all can see, I believe, right? So I would just like to ask our audience some questions, like maybe in the chat you all can share. How many countries have made like successful soft landing on the moon to date? Like, can you name those countries? Anyone? Like you can type in the chat maybe. I'll just take 2 minutes here to get some inputs from you all.
Maybe yes, for in India, yes. It's Russia and
Yes.
USA and Australia.
Including India, we can say that there are 5 countries
India,
like
India.
Russia, Soviet Union, US, China, Japan, and if
Right.
India we can take.
Yes.
Right. And like,
China,
obviously,
Japan, US,
we
then
know that
Soviet Union.
like America did and Soviet Union
Yes,
did.
yes.
And
Yes.
Russia also did, obviously, and China did, and India did. These are the
Japan.
4 first nations. Japan, right? And there are a few more.
And India at last.
Obviously, I did mention
And
India.
India, yes.
Five of them are already there. USA, Soviet Union, or Russia, China, India, and Japan. And then any more?
Australia, maybe.
Not
No,
Australia.
I don't think so.
No, not Australia. Any other?
I don't think so.
Italy, yes.
Italy.
Yes. Italy has not soft landed, I suppose. I suppose it's a like orbiter mission. I think so. Hard landing, Italy has
Israel?
done. Yes.
Israel,
Israel,
any
right? Israel has done. Hard landing.
Yeah, I studied it earlier. That which USA it has tried.
Right.
Yes.
There are a
Nothing.
lot of like there are a lot of countries like beyond Japan, like the till Japan, like USA, Russia, or Soviet Union, or let's be more precise here. Let's say it as Soviet Union, because Russia has not soft landed properly. Soviet Union, when it was there, that has soft landed. Okay, so Russia, USA, Soviet Union, China, India, and Japan. These are the 5 nations that have soft landed on the moon. But then there are multiple examples like Israel and also Russia, like hard landing, because there was one mission which also went along with the Indian Chandrayaan 3, which crashed on the moon. And then ESA also tried, but then unfortunately that was a hard landing. And Luxembourg, obviously. South Korea also tried, right? Somebody said South Korea. And Italy also did one hard landing, if I'm not wrong. UAE also tried to land, to make a soft landing, but it was a hard landing. It was a private mission, actually. And yeah, these are the major hard landings. I'm not much sure about Italy. I need to check that. But then for ESA and Israel and Luxembourg and UAE, they did land like means a hard probe, like a hard landing probe on the moon. So okay, if Italy did it, so for sure Italy, we can also consider Italy for sure. So there are a number of countries that are trying now, and now there are private missions as well. You have heard, obviously, right? So the Blue Ghost lunar lander, which I suppose at the beginning of this year landed on the moon. So there are multiple such attempts that are being made by multiple stakeholders, not just government, but also private endeavors. So this goes on to show that how much important lunar exploration is becoming. Right. Now for the lunar South Pole, choosing lunar South Pole 69.3 degrees south and 32.3 degrees east, that's the exact coordinates for Chandrayaan 3. Some of the major reasons, as I mentioned, that in the initial missions like Chandrayaan 1, higher latitudes were unexplored, like not only in Chandrayaan 1, by other missions as well. Okay. If you see this map properly, most of the landings, like for China or USA or Soviet Union, they are at the center, near to the equator, right? But not very near to the poles. Only China tried one, like Chang'e 3, and then Chandrayaan 3 here. Please note that this particular map of the moon is still India's soft landing, and beyond that, like Japan and other missions, they are not included here. Okay. And obviously the unique conditions, like the sun shines at grazing angle. Basically, there's lesser energy that is that hits the lunar surface in certain regions, and obviously the solar wind ions and electrons to understand these ionospheric studies as well. And most importantly, the topography, the geological mapping of the moon became very important. So that's the scientific motivation behind choosing the lunar South Pole, or near, like a point near the lunar South Pole as a landing point. Okay. And for technological reasons, conditions on global slope in terms of the conditions of size of boulders and craters, and also the shadow analysis, the darker regions. In the darker regions, as I mentioned, like there are certain dark regions in the lunar South Pole where there has been traces of water or water ice that has been found. And then like power generation and communication with the Earth. These kinds of technological demonstrations. For these technological demonstration, the lunar South Pole was considered as a good exploration point, from an exploration point of view, to explore. So for India, that's turned out to be the case, something that has not been done by others. And that is what science is all about, right? Science is not like copying and paste, right? Science is about exploring what others, like building on others' work, and then like expanding, or let's say extending the frontiers of human knowledge, right? So That was the major reason for choosing these coordinates. Now, let's come to just a recap of Chandrayaan 3. Chandrayaan 3 was launched on this GSLV Mark 3, now called the LVM-3 launch vehicle on July 14, 2023. From Sriharikota, we know the launching site for India. And India follows a very, very cost-effective approach and a time-intensive approach in terms of sending these spacecrafts to other celestial bodies, which takes round and round, basically using gravity of the celestial body and then speeding up at particular points so as to increase the size of orbit and eventually literally throw it in a trajectory such that it moves towards the other or the target celestial body. And when it comes under the gravitational influence of that celestial body, again kind of slowing down or kind of reducing the orbit and eventually landing on the target celestial body. So this was considered for our Martian orbiter mission, the MOM, back in 2014, and also for these Chandrayaan missions as well. Okay. And this proved to be very, very cost effective, yet time consuming, to be more apt. Now, one interesting thing, we have often heard about space race, but then Chandrayaan 3's timeline, that was a very unique timeline in the sense that that time we could actually witness a live space race. How? On August, the Chandrayaan 3 was launched on July 14 on launch vehicle, right? And it was tentative to land on the moon around 22nd of August or 23rd of August. Okay. And then there was another mission, Luna 25, from Russia, which was launched on August 11. It would hardly take a few days, like a week's time, to reach the moon, because just in one orbit, it was going to send the spacecraft to the lunar orbit and then eventually landing it near the lunar south pole. So that was not cost effective, though, unlike India's one, but it was very fast because it used a lot of fuel and energy to send or propel the spacecraft towards the lunar orbit. So for Luna 25, which was a moon mission by Russia long after Soviet Union's time, it was perhaps one of the first missions after Soviet Union stopped sending missions to the moon. And India, on the other hand, is taking its second attempt to soft land near the lunar south pole after a part failure of Chandrayaan 2. So it's a race situation where one has started faster, but then is tentatively going to reach late. And on the other hand, one has started late, but is tentatively going to reach faster. Now, who is going to win the race? Right? Who is going to land near the lunar south pole? Right? It was going to make history. Unfortunately, the Luna 25 spacecraft crashed and it lost connection with the station back there in Russia and other parts of the world. So unfortunately, Roscosmos's mission Luna 25 couldn't make it to the moon, which is equally sad as the success, as we feel happy with the success of Chandrayaan 3. Why? Because it's not a space race, however competitive or however country versus country it may be, but then space is not any country's property, right? It's a human endeavor, or a space exploration is a human endeavor, right? So whoever wins, it's not just a win for that nation, it's a win for humanity as a whole, right? Chandrayaan 3's data will be used by America, Russia, China, and other countries. Same goes for other missions as well. So it was sad that Luna 2025 couldn't make it, but at the same time, Chandrayaan 3, in its slow and steady process, ultimately won the race when on 23rd of August, in the evening, as per Indian Standard Time, it soft landed near the lunar south pole. Here's the landing graph you can see, and it took a few more seconds. Actually, I think so. It was around 6:30 in the Indian Standard Time in the evening that this landing happened, and finally, India on 23rd of August 2023, that is exactly 2 years from today, at 18:04 IST, as I was mentioning, like around 6 or 6:30 p.m. Indian Standard Time, it achieved the soft landing on the moon. It became the first country, India became the first country to have achieved soft landing in higher lunar latitudes, and the fourth country ever to have successfully soft landed on the moon or the lunar surface. So with that, India made history. But then, apart from all of this history and all, like there will be more such histories created by India and other nations. But on a personal being, like to me, that day I still remember in the sense that how that day felt like. I essentially stay in Kolkata, and like some of you, those who are from India, may know very well the city of Joy, Kolkata in West Bengal. It's a very vibrant city. So, like there's a science city, which is a very big science center here in Kolkata. So that day in the morning, I visited Science City for some activities and like some outreach activities. But then before the live broadcast of this mission in the evening, I had to come back for some reason. So I was on a public transport from Science City to nearby local railway station, and like around the time of 6:04 IST, I was on a bus on a public transport, and I could see live on YouTube that the soft landing was taking place on ISRO's YouTube channel. And I distinctly remember that, okay, I'm a space enthusiast, it's good. But then, like, alongside myself, there was sitting like some bank employees, or let's say daily wage worker, or let's say even the conductor, let's say the bus conductor. Everyone were kind of like, they were either on mobile watching the live like soft landing, or let's say they were discussing, or like it was a total kind of like the citizens of the country felt like they are a part of this mission, or a part of it was there, or a part of them was there in the mission. Okay, and then I got on a local like train to move to a nearby place. So when I got on the train, I could see a daily wage worker explaining to another daily wage worker that how a proud moment it is for a country like India to reach the moon. And he was explaining that that India is the first country to like land near the lunar south pole. I was getting calls from my family that we have landed, though I knew that, but still, like they have nothing to do with space. But then still they remember that their son, or like I'm associated with the space work and all, and they were quite happy about it. Okay, so then I moved to a place where one of our provisional offices is in Barashat. So there, when I was buying something at the grocery store, the grocery owner was also discussing about Chandrayaan 3 with some of the people coming to buy some grocery. So what I'm trying to say is, it was as if the whole country was rejoicing like on this endeavor. And this is not at all a kind of exaggeration, but a real-time experience what I've felt. And then on social media, you will find tons and tons of videos of, let's say, people on stadiums. Let's say in Kolkata, we have the metro facility where they have launched the like special Chandrayaan 3 like tokens. And then in stadiums and all, let's say when there's a football match, or like FIFA, or let's say Cricket World Cup, when a team wins, as people rejoice, same was that day's story across India and across the globe as well in some parts. So that's what that day felt like to me. This is not something that's like recorded somewhere, or this cannot be cited in scientific literature, but something that I wanted to share with you all. And there lies the success of the National Space Day. There was no Space Day or something before this 23rd of August as such officially declared. Okay, there was National Science Day, but then there was no National Space Day for India. But then Chandrayaan 3, beyond the scientific objective, or let's say this lunar exploration and whatnot, it connected people, it connected hearts. Like even like if you are in India, or you visit like India, if you are from other part of the globe joining us today, you will, when if you visit India, you will find Chandrayaan 3's let's say pictures or murals on the walls, okay, in local streets, or let's say behind a bus, or let's say in rickshaw, or uh, like or in common people's discussion. Like they may not even know the name of ISRO, but they will know the name of Chandrayaan 3. Okay, so there lies the success of this mission, that it connected people like with a greater scientific mission. Unfortunately, science, however important it is in our human life, has not been able to connect people like arts and other fields. But then when a scientific mission, a space mission, connects humans, connects hearts to hearts, connects people, there lies the success of the mission beyond the scientific objective of the mission, right? So that's what Chandrayaan 3 stands for, like to me and to many more. Okay. So that's Chandrayaan 3, a journey. And during its 2 weeks of time, when it got the sunlight from the and the solar panels worked, like it did a lot of activities, let's say from some experimentation on temperature studies, to let's say the lunar the Pragyan rover. As you can see this picture, if you see this picture, the Pragyan rover coming out of um, the Pragyan rover coming out of the Vikram lander. Okay, and then this is the pathway that it traced. You can see the Shiv Shakti point. This is a point where Vikram lander soft landed. That's the name of the point. And it traversed various pathways covering all like more or less more than 100 meters altogether. Okay, to and fro. And then there was also some hopping experiments, like the lunar lander hopped, so that it could be, these kinds of studies can be used for betterment of future missions as well. So all kinds of studies were done. Some of the very important like results from these missions, like initial observations, and then there are published literature you can check out, and there are more in detail studies that are being done till date. Okay, so there was the first ever detection of sulfur, the element sulfur, on the lunar regolith, and also trace constituents of elements like carbon, nitrogen, phosphorus, titanium, manganese, and chromium and nickel. Like they quantified, they kind of measured how much of this particular composition of like elemental composition exists in the lunar sample near that region where they landed. Okay. And there were also some few events of ground vibrations of the lunar surface that were recorded, as you can see here in this